Uh, so guys, sometimes we may encounter questions like this: x minus half less than equal to 2x minus 7. There are two inequalities involved: 3x plus 1 less than equal to 18, comma. So if two inequalities are involved and now we have to find x or the range of x, okay, so in that case what we will do? So intuitively we can say that these two inequalities we have to solve, and we have to take something which is satisfying both. So these type of problems leads us to another concept, as you can predict, that it is about the common solutions. It is about common solution of two or more inequalities. Okay, two or more inequalities, and we call this concept and concept and of two inequalities, guys. It starts with two inequalities. You will start with two inequalities, and we can generalize it for more. So, and of two inequalities, this concept is what we have seen in sets, and is basically this inverted u, okay, this symbol and. So and of two inequalities is basically common solution of the two inequalities. Okay, now how do we find the common solution of two inequalities? It is, the concept is similar to what we did in sets, and of two sets. So these two sets, here we will have the two sets as infinite sets. Okay, so what we have to do, we have to find intersection or common solution. We have to find intersection or solution which is common to both. So how do we find the intersection of the two inequalities? We will see that with some example, guys. So for example, x greater than equal to 2, x greater than equal to 3, comma. Instead of comma, this comma is equivalent to, guys, intersection only. Like instead of comma, if I write this symbol and, it is same. But generally they ask comma is given, which means we have to find the intersection. So what we will do, we will find x satisfying the first inequality, which is x greater than equal to 2. So we will plot 2 first, darken it since equality is there, and we will plot this, the second inequality. We will darken it here, the 3 would be included. Now what we will do, from each of the points we will drop perpendiculars. From point 2 we will drop perpendicular like this on the other number line of the other. From 3 also we will drop perpendicular on the number line of others. Okay, now since we have to find common solution, now we can see here that from 2 to 3 solutions exist, but here it doesn't exist. So since we have to find common solution, so x belonging to 2 to 3, here also 2 to 3, it's not there, but here it is there. So 2 to 3 won't be in the intersection or the common solution. Now here if you can see 3 is included here, 3 is included here. Okay, now values greater than 3 are included here also. So this set of solution is common to both. Okay, so this blue line solution is common to both. So that is the answer. The answer to this is x greater than equal to 3. Okay, the intersection of x greater than equal to 2 and x greater than equal to 3 is x greater than equal to 3 only. So what we have to do, the first step is to, wherever the points that we are marking, from those points we drop perpendicular to the other side, to the other inequality. Okay, so that is a way of finding which part of the solutions are common and which part are not. So next example I will illustrate, you'll understand it more with other example. Like if I take x between -1 to 3, comma x 0 to 2, find x. Since comma is given, we have to find what? We have to find the intersection. So first we will plot the two inequalities. So we will plot this. Okay, so -1 and then 3. We will mark and we will join these two. Now here -1 is included, so we will place a dark circle here. Now the next inequality that we will plot would be x 0 to 2. So 0 lies somewhere between -1 to 3. So 0 I will mark here. Okay, so after marking, now 2 will lie prior to 3 somewhere here. So here I will mark 2 and I will join it 0 to 2. Okay, now 2 and 0 both are excluded. Now we will draw perpendicular from the points. Like here -1 I will draw perpendicular to the other inequality, other number line. Here from 0 I will draw perpendicular. From 2 I will draw perpendicular. Okay, from 3 I will draw perpendicular. Now as you can see, now here also I will plot, write -1, here I will write 0. Now as you can see here, from -1 to 0 there is no x, but here there is x. So their intersection, the common solution, there won't be any x here. -1 to 0, there won't be any common solution. Now here this is 0, here also I will mark 0 and 2. Now here as you can see, 0 is present, 0 is included in -1 to 3, but as you can see here, x0 is not present, 0 is not a part of solution in the second, so 0 we won't take. Okay guys, 0 won't be taken. Okay, then so 0 is not there. Now moving further, 0 to 2 values, 0 to 2 values are present in both. As you can see, 0 to 2, 0 to 2 means both excluded, 0 and 2 are not included. 0 to 2, all the values between 0 and 2, they are included. So 0 I won't take, 2 I won't take, and 0 to 2 values are included, so they will be part of their intersection, guys. So now again moving further, from 2 to 3 there is no x satisfying. Now 2 to 3 there is some x, so their intersection, nothing we will get. So finally the answer is 0 to 2. We can also say that since 0 to 2 is completely a subset of -1 to 3, so the answer is x 0 to 2. or in interval form x belonging to 0 comma 2 both excluded. Let's take another example, guys. X 1 to 10, x 3 to 13. So 1 to 10 I will plot here. Here I will plot 1. Here I will plot 10, and 1 is included, so I will place a dark circle here. Now the second inequality, which is 3 to 13, 3 excluded, 13 included, I will plot. So 3 would be on the right side of 1, so 3 would somewhere lie here. Now 10 is here, so 13 would be on the right side of 10, so 13 would be somewhere here. Now I will join these two guys. Okay, so 3 to 13 is this. Now since 13 is included here, so I will place a dark circle here. After doing this, guys, we will draw perpendiculars. Now from 1 I will draw perpendicular like this. 3 I will draw perpendicular. Okay, 10 I will draw perpendicular. 13 I will draw perpendicular. Okay, now you see here there is a solution from 1 to 3, but there is no x satisfying 1 to 3 here. So in the final solution there won't be any solution between 1 and 3. Here 1 is included, but 1 is not included here, so 1 is not included, 1 to 3 is also not included. Okay, so nothing I will write here. There is nothing here, no solution in their intersection, guys. We are finding the intersection or comma, right? We are finding x. So now here again 3 is included, but 3 is excluded here, so here 3 won't be there. Okay, now 3 moving further, values greater than 3, they are included in both. As you can see, let's say 3.1, so 3.1 is here, here also. Any value greater than 3 is satisfying this part as well as this part till which point? Yes, till x equals to 10. What about 10? 10 is not included here, but 10 is included here. So as you can see, all the values between 3 to 10 we will take. Okay, 3 to 10 we will take, but 10, since it is not common to both, 3 is also not common to both, so it won't be included in the intersection. Now moving on from 10 to 13, 10 to 13 values are included here, but here there is no value from 10 to 13 in the first inequality, so there won't be any common values after 10. So the final solution would be 3 to 10. So x belongs to 3 to 10, open interval, x belongs to 3 to 10, x. Okay, so that way we find intersection of inequality. Now let's do one more example, you can also try it. Okay, x less than 4 less than equal to minus 1 comma, find x. So now again the method is same. We will plot it on the number line, we will draw perpendicular, and we will find the common solution. If you are well versed with, if you have done some good practice, doing it mentally also won't be, won't be an issue. So plotting x less than 4 first, drawing number line, and this we will mark 4 here. Since x is less than 4, all the values lesser than 4 we will take, that is minus infinity to 4 we will take, guys. Now we will plot x less than equal to minus 1. So again 4 minus 1 lies on the left side of 4, so minus 1 will lie somewhere here, minus 1 to infinity, like this. Now sorry, minus infinity to minus 1, minus infinity to 4. Now from 1, if we draw perpendicular like this, and from 4 also if you draw perpendicular, as you can see here in their intersection, minus 1 to 4 there is no values, but here it is minus 1 to 4, here it is values, here there are no values, so no common values between minus 1 to 4. Minus 1 is not included, minus 1 is not there, sorry, minus 1 is there, there is a dark circle here, minus 1 is here also, minus 1 is here also, so minus 1 we will take, guys. Okay, now moving further on the left hand side, all the values lesser than minus 1, and here also all the values lesser than minus 1, they are included. So the finally the common solution would be minus infinity to minus 1, minus 1 included. So that is x belongs to minus infinity to minus 1, minus 1 included, guys. Okay, so hope these examples gave you an idea as to how to find the intersection of inequalities, because in so many questions, if a question involves different uh, methods, sometimes we have to find solution, the final solution we have to find by taking intersection of them. Okay, so this is what we call intersection of two inequalities. Okay, now let's take another example, guys. You can try this as well, x less than equal to 9 and x greater than 7. Find x. Okay, so now I will draw this mark 9 here, x less than 9, so all the values on the left of 9 we will take minus infinity to 9. Okay, and then we will plot this x greater than 7. So x greater than 7, so 7 will be lying on the left hand side of 9 since it is lesser than that. 7 I will mark here, and all the values greater than 7, so I will it has to be on the right hand side of 7. So it is like this, 7 to infinity, minus infinity to 9. So again proceeding with the same concept, we will draw perpendicular from 7, I will draw perpendicular from 9, I will draw perpendicular, this is 9, this is 7. Now as you can see here, from all the values lesser than 7, here it is included, but lesser than 7 values, they are not included here, so it won't be a part of the final solution, that is the intersection. There won't be any values between minus infinity to 7. Okay, now what about 7? 7 is there, 7 is there, but here 7 is not there, so 7 won't be included. Slightly if you take a bigger value greater than 7, 7.001, so 7.001 would be included here. As you can see here, values greater than 7, lesser than 9. Okay, so values greater than 7, lesser than 9, as you can see in both, they are having intersection, they are having common values from 7 to 9. So all the values from 7 to 9 we will take. Now as far as 9 is concerned, 9 is not included here, although 9 is included here, so it won't be a part of their intersection. So 9, it would be an open bracket. So 7 to 9 would be the answer. X belongs to 7 to 9. Okay guys, now we have seen a basic inequality, like if x is, let's say, -1 to 4. Okay, this is one of the basic inequality that we have seen. The meaning of this, as far as and is concerned, it is the intersection of two inequalities, x greater than equal to -1 and x less than 4. So these two inequalities, if you take and, you will always get this. You yourself can try and get this. This is a concept. We can generalize it like this. Okay, if x is from a to b, the meaning of this is x is greater than equal to a and x is lesser than b. Obviously a is lesser than b. Okay, now suppose if here it is equality, equality will be there here. Suppose here equality is not there, here there won't be in equality sign. So that way we can understand this. Okay. So guys, now as I said, we have seen and of two sets. Similar to that, there exist union of two sets. So union of two inequalities, where it is used and why we are doing this, because in some questions, like for example x minus 1 mod 3x minus 1 less than equal to 2, we have to, certain questions we need to solve by taking cases. Like case 1 we have to take, case 2 we have to take, and so on. Case 3 we have to take, and so on. So solving the cases, when we solve a question by taking cases, the final solution guys, it is the union of all the cases involved. The final solution is the union of all the cases involved. Here in this case, let's say if there are three cases, so this is one of the example. This is a question example I have taken from modulus, and you will see it later. You will study it when you will do modulus. So in certain questions, we have to take union of inequalities. Now, if you remember what was union of two inequalities, two sets, what was the union of two sets? Union of two sets is basically collection of set of all solutions of both inequality. It is collection of all solutions of both the inequalities, or if there are more than two inequalities, collection of all solutions of all the inequalities involved in the union. Okay, so inequality, union of two inequalities, union, we have seen intersection, union is denoted by u, the symbol u. Okay, so if we are doing, u is used as the union symbol, guys. This is used as a as a method of taking union of inequalities two or more, and this is used as a symbol, as a connector in representing inequality in interval form. That also, that we will see. Okay, this is used as a symbol also, not only as a operator, for example, sometimes the answer may look like this: minus infinity to minus 1 union 3 to infinity. So union is this is used as a symbol or a connector between different solution of lying on the number line. Okay, so u is used both as a symbol and as an operator. How we use union, how we do union, that we will see now, guys. Okay, so let's take example x less than equal to 3, or we also represent u by or. Okay, u and or are used, they are the same. Okay, x less than equal to 3, x less than 7. So we will draw a number line. We will first plot this, we will mark 3, we will x less than equal to 3. Okay, and then all the values lesser than 3 we will take. 3 is included here. Now the second x less than 7 we will plot. 7 lies on the right side of 3, so somewhere it was here, so I will plot 7 here. Again x is less than 7, so all the values lesser than 7 we will take. So minus infinity to 3 in the first case, 3 was included. Minus infinity to 7, 7 is not included. Again the concept is same, we will draw perpendicular from the points, okay, where the inequality is starting. So 7, 3, I draw perpendicular. Now as you can see here, guys, we are doing union. Union means what? Take everything, whatever this inequality has, whatever this inequality has, whatever the common inequality solutions they have, everything we have to take. Like from 3 to 7, this has values, this doesn't have values, doesn't matter. 3 to 7 we will take, because we have to take collection of, we have to take all the solutions of both the inequalities, whether common, like here they are common from minus infinity to 3. From 3 to 7 they are not common. Okay, so whatever the common or not common solutions, everything we have to take. So it will go on like this. Answer would be minus infinity to 7, guys. Okay, x belongs to minus infinity to 7. Okay, so likewise we can do things. We can take some example, previous examples of and we can do them, we can take their union. Okay, like let's start with this. Now if we have to, let's say if we have to find or, okay, the question is like this, guys. So in this example we have to find or x less than equal to 9 or x greater than equal to 7. Okay, guys, this again, this also I will rub. So what we will do, as you can see here, after plotting x less than equal to 9, okay, 7 to 9 is the common solution, minus infinity to 7 is uncommon solution. Whatever it is, whether it is common, whether it is this is uncommon solution from minus infinity to 7, we will take, because it is union. it is not intersection. Okay, this is union, guys. And from 7 to 9 it is common, that also we will take. Okay, so 7 to 9, 7 is a part of this, it's not a part of this, so 7 also is there. So minus infinity to 9 we will take. Now since 9 is not a part of, since 9 is a part of this, that we will take. And now from 9 to infinity also we will take, so it will be the entire number line, guys. What I mean to say is x belongs to minus infinity to plus infinity, that would be the solution. Equivalently, x belongs to R can also be written, guys. Set of all real numbers, or if you write minus infinity to plus infinity, that is also correct. Both are same, guys. Okay. Now, previous example. Now, let's do it on a fresh board, because so many things are written. It may not bring that clarity. So we will do another example on a fresh board, guys. Hope you understood that example. Now I will do it again. We will write it again. No problem. X minus 2 to 3 to 7, let's say, union x 5 to 10. Find the union of these two. So guys, we will draw minus 2 to 7. We will plot minus 2 and 7 here, let's say. Now the second inequality, in the first inequality 7 is included, so 7 we will place a dark circle here. Now in the second inequality 5 is on the right side of minus 2, it will lie somewhere here. So 5 I will plot here, and 10 would be on the right side of 7. 10 would be somewhere here, so it would be here like this, 5 to 10. Okay, we are finding what? We are finding the union. So again we will draw perpendicular from these points where the inequality is starting or ending. So minus 2, we will draw perpendicular. So as you can see here, from minus 2 to 5, minus 2 is not here, it is not here, so it won't be a part of their union. Although from minus 2 to 5, minus 2 to 5, there is no x here satisfying this, but minus 2 to 5, definitely the first inequality has x. So we will take, since we are taking union, we will take all the points from minus 2 to 5. Okay. Now moving on, 5 is included here. Although 5 is not included here, so 5 would be there. Values greater than 5 are now common to both. Okay. So these values greater than 5, here also greater than 5 values would be common to both. So I will stretch this solution further and further till 7. Now 7 is included here, it is included here also, so 7 is also included in the solution. Now moving ahead, after 7 to 10, x is satisfying this, but here there is no x, 7 to 10. So 7 to 10 also we will take, because we are taking the collection of both the solutions. So 7, so minus 2 to 10, finally we will take. So 5 and 7 will also be a part of it. So finally minus 2 won't be there, 10 won't be there. So the answer is x belongs to minus 2 to 10. Okay, that is the union. Hope you understood it. Let's take another example, guys. the union of two. Okay, let's take another example, guys. Now, guys, if suppose x is less than 5 or x is greater than equal to 19 by 2, we have to find the union of these two. Again, we will plot this 5 x lesser than 5, so we will take all the solutions on the left of 5, minus infinity to 5 it is. Now 19 by 2 is equal to 9.5, so 9.5 is on the right side of 5, so it is somewhere here. Let's say 19 by 2. Now x is greater than equal to 19 by 2, so all the values greater than equal to 19 by 2 we will take. So 19 by 2 to infinity it will be, 19 by 2 is included. Now if we have to take union, so this is what I was saying in the beginning. This is the illustration of using union as a symbol. As you can see here, minus infinity to 5 is here, but there is no x here, since we are taking solution which is satisfying both or any one. Okay, that is the union. So we will take minus infinity to 5 in our solution set of the union. Now 19 by 2 to infinity is there here, but here there is no value. So we will take 19 by 2 to infinity here. If we did by the same, either you draw it or you can do it directly also by dropping perpendicular. So 19 by 2 to infinity. Okay, so this is the union of the two inequality. So x belongs to, now the question arises, how do we write this? Because so far what we did, there was only one portion, one continuous portion of inequality solution on the number line we used to have. Now we have two portions of solutions scattered on the number line. One is this, and 19 by 2 to infinity is also there in our solution set, which is also there. So since there are, if there are more than one solution set on the number line, we write all of them and we connect them by this symbol u. So this is what I mean to what I meant in the beginning, that u is used as a connector, as a symbol to connect the different solutions on the number line. So this is a this symbol u is used as a connector, and u as a concept also we have seen, which is the union of two solution, two inequalities, means take all the solution which is common to both, or which are not common also we have to take all the solutions. That is what we mean by union. So and u as a connector also we have used this. Let's take another example about the usage of the connector u, like this. If I write one of the solution set on the number line like this, guys, minus infinity to minus 4, 0 to 3, 0 included, and 10 comma 10 to infinity. How do you write it in interval form? Write the solution in interval forms. How you will write? Okay, so again, you might have correctly guessed it. We will start from the left hand side. There are three set of solutions which are there, which are present on the number line, which are scattered on the number line. One is this, another is this, another is this. So we will write all the three and connect them with the connector, yes, u. So minus infinity to minus 4, union 0 to 3, 0 is included because 0 is dark circle here, so we will place a square bracket here. union 10 which is not included, so open bracket or round bracket 10 to infinity. So there are two connectors we use here, one and another. Okay, so that's the use of the connector. Another example of use of u, let's take, again we have to write in the form of 4 by 3 to 21 by 2, 13, 100, 400. Now we have to represent it in interval form. Okay, we have to write this in interval form. So how do we do this, guys? Now as you can see here in this is a unique example in which so far we have seen a continuous, set, an infinite set of inequalities from point A to point B, or from A to infinity, or from minus infinity to B. But here, as you can see here, we have taken this question is having, we have to include these discrete points in the solution set. So how can we do that? So x belongs to, we can write it like this, guys. 4 by 3 is included to 21 by 2 which is excluded, so round bracket. Now please see this union. Now discrete points, we have seen in set theory, they are written inside set of curly braces separated by comma, 1300, 400. That way we can write, guys. Okay, so that's a way of writing solution set in interval form. And let's take one more example. 4 to 13, this is 10. Now this 10 means what? As you can see here, the solution set is write in interval form. Again the question is same, write it down in the interval form. So what we will do, either we can write, we have two options of writing this, guys. First we can write it like this, 4 to 10. As you can see, 10 is not included here. This means 10 is, there is a break at 10. So we will take a break at 10, we will use a round bracket. Then again we will start from 10, starting with a round bracket till 13. Again round bracket, open interval. Since 13 not included, now we will connect it by u. This is one of the way of writing it. Or else we can write it like this, x belongs to 4 to 13. But since 10 is not there, this 10 alone would be written inside the pair of curly braces, and now we will write this sign, minus sign. Yes, so minus sign can also be written, guys. Okay, so using minus also we can write it down, guys. Using minus, the way of writing it in terms of minus, that we can do the use of minus in representing solution in interval form can be uh, done. Let's take another example illustrating the same. Like we did a previous example similar to that, I will write minus infinity to 4, and this is, let's say, 11 to infinity. Write the solution. Okay, so what we did in the previous examples, from there you will write it like this, minus infinity to 4, and then 11 to infinity you will write, and connect them with this connector u. This is what we did in the previous example. So there is one more way of writing it in the form of interval using minus. What we will do, we will write minus infinity to plus infinity. We will take full, So minus infinity to plus infinity we have taken, but we need to exclude the solutions from 4 to 11 which are not there, which are not a part of the solution. So here we will separate, we will subtract, we will use this minus sign in representing the solution 4 comma 11. Now my question to you guys is, here 4 curly bracket will come, sorry, square bracket will come or round bracket will come? So 4 should not be, must not be a solution. So we are subtracting 4. So if you take square bracket, 4 would be excluded from this, which is correct. So we will use a square bracket. This means 4 will have to subtract. So that is correct, because 4 is not a part of the solution. As you can see here, 4 is in the open bracket. And what about 11? Since 11 is a part of a solution, we cannot use square, so we will use open. So till 11, all the values from 4 till 11, but not 11, needs to be subtracted. So it means 11 is there in the solution, minus infinity to infinity, minus 4 to infinity, because 11 we put what, we put an open bracket. So always remember that these kind of inequalities, if here it is open, by while doing minus we have to put close. If here it is close, we have to put open here. Okay, so that sums up our discussion on union intersection. One example about intersection I wanted to give guys, like one set also comes, like similar to the previous problem. Now I will give intersection of these two. Union would be definitely this only. Okay, this or this, whatever the way you want to write. Now my question here in this example is the intersection of these two. Now as you can see here, if you draw perpendiculars for 11, there won't be any common solution. There is common solution, there is uh, solution here, but there isn't here. Nothing here as well as here. Here there is nothing, here there is. So intersection we won't get anything. So we won't get anything means what? This is the answer. There is no solution to this. No solution. We write it using this symbol x belongs to phi. Okay. Phi is a null set. Phi is null set. Okay. So we use this symbol. No solution is equivalent of writing x belongs to phi. Okay. Okay guys.